AI-driven transportation refers to the integration of artificial intelligence into vehicles and transportation systems, enabling autonomous movement and intelligent decision-making. This concept encompasses technologies like machine learning, computer vision, and advanced sensor fusion, allowing vehicles to perceive their environment, process data, and make real-time decisions without human intervention. AI-driven transportation represents a transformative shift in how we perceive and interact with mobility, promising enhanced safety, efficiency, and convenience. The significance of AI-driven transportation cannot be overstated. It holds the potential to revolutionize industries, urban planning, and daily life. By reducing human error, which accounts for a significant portion of traffic accidents, AI systems can enhance road safety. Additionally, AI-driven vehicles can improve traffic flow and reduce congestion through smart routing and adaptive traffic management systems, ultimately leading to more efficient use of infrastructure and lower emissions. Two standout examples of AI-driven transportation in action are autonomous cars, like those developed by Waymo, and AI-powered public transportation solutions, such as the self-driving buses being tested in various cities worldwide. Waymo, a leader in the autonomous vehicle market, utilizes a combination of sensors, cameras, and AI algorithms to navigate complex urban environments with minimal human input, showcasing the potential for fully automated personal transport. Meanwhile, AI-driven bus systems are advancing public transit by providing on-demand, flexible routing that adapts in real time to passenger needs, significantly improving accessibility and reducing idle time. Critics of AI-driven transportation often raise concerns about safety and ethical implications. While AI has the potential to reduce accidents, the technology is not infallible, and high-profile incidents have highlighted the need for robust safety protocols and testing. There's also debate over job displacement, with concerns that widespread adoption of autonomous systems could threaten employment in the transportation sector. Despite challenges, AI-driven transportation heavily influences other aspects of transportation innovation, such as electric vehicles and smart city development. By integrating AI capabilities, the transportation ecosystem becomes more interconnected, paving the way for seamless multimodal networks where different transport modes work in harmony. The adoption and integration of AI-driven transportation solutions will likely redefine mobility, setting the foundation for a more sustainable and efficient future. AI-driven transportation, specifically through autonomous vehicles, represents a groundbreaking shift in how we approach mobility by leveraging artificial intelligence to enable vehicles to operate without human intervention. This innovation is pivotal to the broader theme of AI-driven transportation, as it promises to redefine travel, enhance safety, and improve efficiency. At its core, autonomous movement involves the use of sensors, cameras, radar, and advanced algorithms to interpret traffic conditions, navigate routes, and make real-time decisions. The significance of this development is immense in its potential to revolutionize transportation. First, it has the potential to dramatically reduce traffic accidents, which are predominantly caused by human error. Secondly, autonomous vehicles could enhance mobility for those unable to drive, such as the elderly and disabled, effectively democratizing transportation. Moreover, AI-driven cars could optimize traffic flow, reducing congestion and emissions, and contributing to a more sustainable urban environment. Real-world applications of this technology are already visible. Companies like Waymo, a subsidiary of Alphabet Inc., operate autonomous taxi services in select cities, offering a glimpse into a future where transportation is both convenient and efficient. Tesla's deployment of its full self-driving software aims to make personal vehicles capable of navigating highways and inner-city roads with minimal human oversight, further illustrating the practical application of AI-driven transportation. Supporters of autonomous vehicles often cite their promise to enhance road safety and transform urban planning by freeing up space currently devoted to parking. However, the path to widespread adoption is fraught with technical, ethical, and regulatory challenges. The technology must robustly handle complex driving environments, a task not yet fully realized. Furthermore, there are concerns about job displacement for professional drivers and ethical dilemmas in decision-making during unavoidable accidents. This innovative movement directly influences other aspects of transportation, such as infrastructure development, which must evolve to accommodate autonomous vehicles. It also prompts a reevaluation of public transit systems, potentially integrating autonomous vehicles for first-mile and last-mile connectivity. The intersection of AI-driven vehicles with other smart transportation solutions, such as traffic management systems, further emphasizes the interconnectivity and transformative potential of AI in transportation. As society stands on the cusp of this transition, the successful integration of autonomous vehicles will depend on overcoming technological hurdles and addressing societal concerns, representing both an opportunity and a challenge for future mobility. Core technologies. Behind autonomous movement refers to the foundational systems and innovations enabling the development and deployment of self-driving vehicles. These core technologies include sensors, machine learning algorithms, advanced computing, and vehicle-to-everything communication. Sensors such as LiDAR, radar, and cameras provide the vehicles with a comprehensive view of their surroundings. Machine learning algorithms process this data to interpret the environment, make decisions, and learn from drivers' patterns. Advanced computing systems offer the processing power needed to handle vast amounts of data in real time, ensuring safe and efficient navigation. The significance of these technologies in AI-driven transportation is profound. They are the backbone of autonomous vehicles, enabling them to operate without human intervention. By facilitating safer, more efficient, and potentially more environmentally friendly transportation, these technologies hold the promise to revolutionize the way we move. They also contribute to decreasing traffic accidents caused by human error, which account for a significant portion of road casualties. Real-world applications are already demonstrating the potential of these technologies. Tesla's autopilot system uses a combination of cameras, ultrasonic sensors, and radar to enable semi-autonomous driving, assisting with tasks like lane keeping and adaptive cruise control. Another example is Waymo, a company that has been testing its self-driving technology via a fleet of autonomous taxis in select cities, showcasing a creative use of LiDAR and machine learning to safely navigate urban environments. Supporters of AI-driven transportation argue that these advancements could lead to a future where traffic congestion is minimized, road safety is maximized, and accessibility for individuals who are unable to drive due to age or disability is significantly improved. However, there are challenges and controversies. Concerns over data privacy, the reliability of current technology under adverse conditions, and ethical considerations in decision-making algorithms remain. Moreover, the transition towards autonomous vehicles poses economic challenges, potentially displacing jobs related to traditional driving roles. These core technologies are intricately connected to other aspects of AI-driven transportation. They enable new business models, such as ride-hailing services that could eventually transition to autonomous fleets. Furthermore, they influence regulatory and infrastructural developments, as governments must adapt to accommodate and legislate these new forms of mobility. As progress continues, the interplay between technology, society, and policy will shape the evolution of autonomous transportation, driving us closer to a future where AI seamlessly integrates into our daily commutes. In the rapidly evolving landscape of AI-driven transportation, the concept of autonomous vehicles stands as a cornerstone. Autonomous vehicles, often referred to as self-driving cars, utilize advanced technologies such as artificial intelligence, machine learning, and sensors to navigate and operate without human intervention. These vehicles rely on a complex system of cameras, radar, and LiDAR to interpret their surroundings and make real-time decisions, enabling them to traverse roads safely and efficiently. The significance of autonomous vehicles in AI-driven transportation cannot be overstated. They promise to dramatically reduce accidents caused by human error, which accounts for a significant majority of traffic accidents. Moreover, autonomous vehicles are expected to enhance mobility for those unable to drive, such as the elderly or individuals with disabilities, thereby promoting inclusivity in transportation. They also have the potential to optimize traffic flow and reduce congestion through precise driving patterns and effective communication between vehicles. Real-world applications of autonomous vehicles are burgeoning. For instance, companies like Waymo have been testing and deploying self-driving taxis, providing a glimpse into a future where hailing a ride does not necessitate a human driver. Another example is in the logistics sector, where autonomous trucks are being piloted by companies such as Too Simple to transport goods more efficiently across long distances, indicating a significant shift in the freight industry. Supporters of autonomous vehicles argue that their widespread adoption could lead to a major decrease in traffic-related fatalities and a more sustainable use of road infrastructures. However, there are challenges and controversies inherent in this innovation. Concerns around the safety and reliability of autonomous vehicles remain, especially in complex urban environments with unpredictable variables. There are also ethical considerations regarding decision-making processes in critical situations, known as the trolley problem. Additionally, the potential impact on employment, particularly for drivers, poses economic and social challenges. The development and integration of autonomous vehicles inherently influence other aspects of AI-driven transportation. As they become more prevalent, there will be a pressing need to advance infrastructure, such as smart roads, that can support these vehicles. Furthermore, legislative and regulatory frameworks will need to evolve to accommodate this new mode of transport, ensuring it is both safe and equitable. Ultimately, autonomous vehicles represent a transformative element in the broader narrative of AI-driven transportation, paving the way for a future where mobility is not only more accessible and efficient, but also inherently intelligent.